Write down the question. So for example, it is a pulley. So here force applied 100 newtons. So draw the figure. It is 5 kg block and it is 10 kg block. So force applied 100 newtons. Force applied 100 newtons. Write down the question. Find acceleration of each block. Find acceleration of each block. Okay, listen, in this case, so here these are the ideal pulleys. Ideal pulley means massless pulley. In the case of massless pulley, the forces will be balanced. So if it is 100 newtons, in this string 15 newtons, in this string 15 newtons will be present. So 15 Newton, and totally balanced by 100 newtons. So in the case of ideal pulley, means massless pulley, in the case of massless pulley, resultant force 0. Resultant force 0 means the forces are balanced. If it is 100 newtons, equally divides, like 15 Newton equally divides. So in this case, in this string, tension force 15 newtons. In this string, tension force 15 newtons. Okay. So in this string, tension force 15 newtons. In this string, tension force 15 newtons. And before that here, so it is a 5 kg block. So mass is a 5 kg. So its weight 15 newtons. Its weight 15 newtons. Then after, its mass 10 kg. So weight is 100 newtons. Okay, that means in this case, to lift this 5 kg block, minimum we require 15 newtons. To lift this 5 kg block, minimum we require 15 newtons. In the same way, to lift this 10 kg block, minimum we require 100 newtons. Okay, so these are the minimum values we require. So to lift 5 kg block, minimum we require 15 Newton force. To lift 10 kg block, minimum we require 100 newtons force. Okay, so here initially 100 newtons is given, so equally divided, like 15 Newton and 15 Newton. Same thing. Now in this string, tension force 15 Newton, and here equally divides. So it is a 25 Newton and this is 25 Newton. So 25 Newton, resultant becomes 15 Newton. So this 100 Newton equally divided. Again this 15 Newton equally divides. So if it is a 15 Newton, in this string, tension force is 25 Newton. Same thing in this string, tension force 25 Newton. So here in this string, tension force 25 Newton, in this string, tension force 25 Newton. And for 5 kg block, with respect to 5 kg block, what is the direction of tension force away from the body along the string? So with respect to 5 kg block, direction of tension force, okay, that is away from the body along the string. So here it is the direction of 25 Newton force. Same thing, it is the direction of 25 Newton force. So I told you already, so to lift 5 kg block, minimum we require 15 Newton. But in this case, what is a lifting force? Lifting force, tensional force is only 25 Newton. So this lifting force, this tensional force, only 25 Newton. So this 25 Newton is not sufficient to lift a 5 kg block. This 25 Newton is not sufficient to lift 5 kg block. So in this question, acceleration of 5 kg block is 0 because it is not lifted. It is not lifted. So acceleration 0. So still at a rest position. In the same way, in the case of 10 kg block, to lift a 10 kg block minimum we require 100 newtons. To lift a 10 kg block minimum we require 100 newtons. But in this case, what is a lifting force? Lifting force is only 25 Newton. Now this 25 Newton is not sufficient to lift a 10 kg block. This 25 Newton, so this lifting force 25 Newton is not sufficient to lift 10 kg block. So still 10 kg block at rest position because it is not lifted up. So it is not lifted up, so its acceleration also 0. So acceleration of 10 kg block is equal to 0. So it is a question. So what is the question? We have to find the acceleration of each block. Now this block acceleration 0 and this block acceleration also equal to 0. Yeah, note down please. Next example. So for example, here we have a pulley. So applied force is given 300 newtons. Applied force 300 newtons. And same thing here, we have another pulley. Okay, same above question, simply values we are changing. So it is 5 kg block, it is 10 kg block. So in the previous question, applied force 100 newtons, and in this case, I'm taking applied force 300 newtons. I'm taking applied force 300 newtons. And same question, find the acceleration of each block. Find the acceleration of each block. Find the acceleration of each block. Okay, same procedure like previous we have to follow. It is 300 newtons. So here it is ideal pulley, so massless pulley. So it is a massless pulley, so the forces will be balanced. If it is 300 newtons, equally divides like 150 Newton in this string and 150 newtons in this string. So force equally divides. So in this string 150 Newton, same thing in this string 150 Newton. Then after it is 150 Newton and it is an ideal pulley. Same thing, this force equally divides. So like 75 Newton, 75 Newton. So now in this string, tensional force 75 Newton. In this string, tensional force 75 Newton. So here mass is a 5 kg, its weight is a 50 newtons. Here mass is a 10 kg, its weight is 100 newtons. Then after, so in the case of 5 kg block, what is the direction of tensional force? In the case of 5 kg block, direction of tensional force away from 5 kg block along the string. So here it is the direction of tensional force. And what is the value of this tensional force? 75 Newton. In the same way, in the case of 10 kg block, it is the direction of tensional force. And what is the value of tensional force? 75 Newton. Okay. So in this string, tensional force 75 Newton. in this string tension force 75 Newton, but it is a 10 kg block. So in the case of 10 kg block, to lift this 10 kg block, minimum we require 100 Newton force. To lift a 10 kg block, minimum we require 100 Newton force. But in this case, what is the lifting force? The lifting force only 75 Newton, but minimum we require 100 Newtons. But in this case, the lifting force only 75 Newton. So because of 75 Newton, this 10 kg block is not lifted up. So due to 75 Newton, this 10 kg block is not lifted up. So this 10 kg block still at rest position, so that acceleration of 10 kg block is equal to 0. So why? Because 10 kg block is not lifted up, still at a rest position, so its acceleration is 0. And in the case of 5 kg block, minimum we require 15 Newton to lift. Minimum we require 15 Newton to lift. But in the case of 5 kg block, so here the lifting force, tension force 75 Newton. So this 75 Newton can lift this 5 kg block. This 75 Newton can lift this 5 kg block. So therefore, if we draw 5 kg block separately and according to its free body diagram, in the case of 5 kg block, its weight is 15 Newtons, but lifting force, tension force is 75 Newton. So this 75 Newton is enough sufficient to lift 5 kg block. Okay, this 75 Newton is enough sufficient to lift 5 kg block. So therefore, it will be lifted up. So it is a direction of motion. Therefore, we are finding dynamic equation in the case of 5 kg block. So what is the dynamic equation? So here direction of motion upwards. In upward direction 75 Newton, in opposite direction 50 Newton. So therefore, resultant force acting on 5 kg block is 75 minus 50. Why? Because both forces acting in opposite direction. So resultant force acting on 5 kg block is equal to 25 Newton is the resultant force. Resultant force means mass into acceleration. So 5 kg is the mass, its acceleration we are finding equal to 25. Therefore, A equal to, we get 5 meter per second square. So it is acceleration of 10 kg block and this is acceleration of 5 kg block. Note down this question. Note down next question. Okay, same numbers I'm taking, 5 kg block, 10 kg block. For example, it is a pulley. Now applied force is given 500 Newtons. Applied force 500 Newtons. Then after, and here we have another pulley. And this block mass 5 kg. And this block mass 10 kg. The question is find acceleration. Find acceleration of each block. Find acceleration of each block. Write down the question. And same process let us follow. If it is a 500 Newtons, equally divides. So 250 Newtons and 250 Newtons. So here in this string, tension force 250 Newtons, and in this string, tension force 250 newtons. And same process, so it is 250 newtons, same equally divides. Now in this string tension force 125 newton, in this string tension force 125 newton. So in this string tension force becomes 125 newton, and in this string tension force becomes 125 newton. So 5 kg block, so weight 50 newtons, 10 kg block, its weight 100 newtons. So for 5 kg block, it is the direction of tension force upwards. For 10 kg block, it is the direction of tension force upwards. In this case, in the case of 5 kg block, to lift 5 kg block, minimum we require 50 Newton force. To lift 5 kg block, minimum we require 50 Newton. But in this case, the lifting force is 125 Newton. So this 125 Newton is enough sufficient to lift 5 kg block. In the same way, in the case of 10 kg block, to lift 10 kg block, minimum we require 100 newtons. But in this case, the lifting force is 125 Newton. So this 125 Newton is enough sufficient to lift a 10 kg block. This 125 Newton is enough sufficient to lift 5 kg block. So therefore, the both blocks will be lifted up. So why? Because the forces are enough sufficient to lift them up. So both blocks will be lifted up. So therefore, I'm taking first of all 5 kg block. So we are taking 5 kg block and we are writing resultant force. Resultant force acting on 5 kg block. In the case of 5 kg block, so it is 125 Newton, it is 50 Newton, and both forces in opposite direction. So resultant force is equal to 75 Newton. So 75 Newton is a resultant force acting on 5 kg block. Resultant force means mass into acceleration. Mass 5 kg into acceleration equal to 75 Newton. By simplifying it, we get acceleration equal to 15 meter per second square. It is acceleration of 5 kg block. In the same way, next we are taking 10 kg block. In the case of 10 kg block, so we have to find resultant force acting on 10 kg block. In one direction, lifting force 125 Newton, in opposite direction 100 Newtons. Therefore, on 10 kg block, resultant force acting is 25 Newton. So in the case of 10 kg block, resultant force is equal to 25 Newton. Resultant force means mass into acceleration. Mass is a 10 kg into acceleration A equal to 25 Newton. Therefore, acceleration equal to, it is 2.5 meter per second square. It is about acceleration of 10 kg block. Note down. Right down. Next question. Next question, some difficulty one. For example, it is a pulley, and here we have a block, and same thing here we have a block. So it is 1 kg block and it is 2 kg block. 1 kg means its weight 10 newtons, and 2 kg block its weight 20 Newton. Okay, and here we have force applied, F equal to 20 T. Applied force 20 T. Now this applied force is a variable force. Okay, why? Because as the time changes, this applied force also changes. As the time changes, this applied force also changes. So it is a variable force. And like same process we have to apply. If it is a 20T, equally divides. So in this case, tension force becomes 10T, and in this case, tension force becomes 10T. Then after, in the case of 5 kg block, so in the case of 1 kg block, so with respect to 1 kg block, what is the direction of tension force is away from 1 kg block, means in upward direction. So in the case of 1 kg block, it is the direction of tension force. Same thing in the case of 2 kg block, it is the direction of tension force. So here as a time, so it is a tension force in this string, and this also tension force in this string. But what type of tension force? Variable tension force, because this tension force is a function of time. This tension force is a function of time. So as the time changes, tension force also changes. As the time changes, tension force also changes. Okay, so it is a 1 kg block. It is a 1 kg block. To lift 1 kg block, minimum we require 10 Newton force. Okay, this 1 kg block, to lift 1 kg block, minimum we require 10 Newton force. And in the case of 2 kg block, to lift 2 kg block, minimum we require 20 Newton force. Okay, write down the question. Find velocity of 1 kg block. Find velocity of 1 kg block when 2 kg block just lifts from the ground. Find the velocity of 1 kg block. So we are finding velocity of 1 kg block when 2 kg block just lifts off, okay, from the ground. Okay, listen. Yeah, please note down first question. Okay, just a minute, please. Just a minute. Okay, now you please answer. Now, at what time this 1 kg block, the question is at what time this 1 kg block just lifts off from the ground?
1 second.
1 second. Okay, if t equal to 1 second, now tension force, lifting force becomes 10 Newton, this also 10 Newton. So write down first step. At t equal to 1 second, 1 kg block just lifts from the ground. Now you please answer. Now this 2 kg block, at what time it just lifts off?
2
seconds. 2 seconds.
Write down. At t equal to 2 seconds. 2 kg block just lifts from the ground. Okay, so the question is, we have to find the velocity of 1 kg block. Okay, we have to find velocity of 1 kg block when 2 kg block just lifts off from the ground. Okay, that means here this 1 kg block will be lifted up at t equal to 1 second. This 1 kg block lifted at t equal to 1 second, and this 2 kg block lifted at a t equal to 2 seconds. Okay, that means the question is we have to find the velocity of 1 kg block at a t equal to 1 second or at a t equal to 2 seconds. At what time we have to
At
find
t
out?
equal
2
to 2
seconds.
seconds.
2 seconds. So at t equal to 2 seconds, what is the velocity of 1 kg block? That velocity we have to find out. But in this time interval, 1 second to 2 seconds. So we are finding velocity of 1 kg block at 2 seconds. Okay. But at 1 second, this 1 kg block lift at t equal to 1 second, this 1 kg block lifted up. But in this time interval, 1 second to 2 second, so 1 kg block velocity is uniform or non-uniform?
Non-uniform.
Why non-uniform? Because tensional force is a
Because
constant tensional force or the variable tension force?
Dependent on time.
Variable tension force. Okay, so in this case, we have to follow integration process. But in this integration process, what are the limits of time we have to consider from? So 0 to 1 second.
And 2 seconds.
Perfect.
1
So
to
1
2
second,
seconds.
1 to 2 seconds, those are the limits. Okay, but we are finding velocity of 1 kg block at what time?
2 seconds.
2 seconds. Okay, so in the case of 1 kg block, you please answer. In the case of 1 kg block, what is the resultant force acting on it? Resultant force acting on it. It will be lifted up. So it is the direction of motion.
10
10t minus
10
10.
minus 10 Newton.
10t minus 10. Okay. Resultant force means mass into acceleration. Mass is 1 kg block and acceleration means dv by dt. Okay. So resultant force means mass. Mass is 1 kg block and acceleration dv by dt equal to, on right hand side we have 10t minus 10. From this equation dv equal to, so you take dt value to right hand side, dt to right hand side, so we get 10t dt minus 10 dt. If we do
Can you
integrate,
explain how F net comes dv by dt, sir? I got disconnected, sir, please.
so resultant force means what is the formula? Mass
into acceleration.
acceleration dv by dt na?
Yes.
So resultant force is mass into acceleration.
Okay, sir. That is one. That
It
is one
one
mass. Oh, I thought that is question number. Oh, sorry.
No, it's 1 kg, 1 kg block.
Okay, 1 kg. Okay, thank you, sir.
So by doing integration of dv equal to integration of 10t dt minus integration of 10 dt. So here on right hand side, this integration with respect to time, so time limits. This integration with respect to time, so time limits we have to write. So what are the lower limit of time? Lower limit 0 second or 1 second?
1.
1.
0 second.
So 1.
0 second and final limit is 1 second.
So lower limit is 1 second.
1 second.
Why 1
So
second?
1 to 2.
Because
1 to 2 are the limits.
Correct. Why? Because this 1 kg block will be lifted up at t equal
1
to
second.
0 time. Correct. At t equal to 1 second, this 1 kg block will be lifted up. So at t equal to 1 second. So 1 second is the lower limit. So at 1 second and at t equal to 1 second, 1 kg block will be lifted up. Then after at t equal to 1 second, t equal to 1 second, what is the velocity?
V initial.
Okay, 0 na?
0.
Why 0? Because if t equal to 1 second, so then what about this applying this tension force value at t equal to 1 second?
Both are
10.
equal.
So both are equal. Now both will be balanced. If both will be balanced, the resultant force is 0, acceleration 0. So still at a rest position, so velocity is 0. So at t equal to 1 second, velocity 0. The 1 kg block is ready to lift up, but not lifted. At t equal to 1 second, 1 kg block is ready to lift, but not lifted. So at t equal to 1 second, velocity of 1 kg block is 0. Then what is the upper limit of time we have? 2
So
seconds.
2 seconds.
So at 2 seconds, what is the velocity of 1 kg block that we are finding? Okay, we are finding velocity of 1 kg block. So at t equal to 2 seconds, we are finding velocity of 1 kg block. Now you do integration and simplify, find out v value. Do it, let me know the final answer. You do integration, take the limits and simplify.
Five meters per second.
Correct.
So 5 meters per second.
Correct. So V equal to 5 meter per second. So I told you already at a t equal to 1 second. So keep the mic off. If completed, please keep the mic off. At a t equal to 1 second, 1 kg block is so ready to lift off from the ground. Ready to lift off from the ground. So at a t equal to 1 second. At a t equal to 2 second, 2 kg block ready to lift off. Okay, someone mic is on still. So here 1 kg block. So at t equal to 1 second. At t equal to 1 second, 1 kg block ready to lift off from the ground. At t equal to 2 seconds, so 2 kg block ready to lift off from the ground. So minimum means 10 newtons we can say. A 10 Newton force ready to lift. At 20 newtons ready to lift. So that is the meaning of this statement and this statement.
Sir, so
Right.
we are saying
Please.
by that statement that after 1 second it is going to be lifted off.
Okay, so even if it is 1.00001 second, it will be lifted up.
Yeah.
Okay. Note it down.
Yes, sir.
Write down next concept. Frame of reference. Next concept, frame of reference. Frame of reference. So what is the meaning of frame of reference? Write down. The coordinate system required to explain motion of a body is frame of reference. Okay, FOR, frame of reference. So the coordinate system required to explain motion of a body is nothing but frame of reference. Next point, frame of reference is two types. Frame of reference is two types. First one is inertial frame of reference. Inertial frame of reference. Okay, simply we follow IFOR, means inertial frame of reference. And second one is non-inertial frame of reference. Okay, simply we follow NIFOR, non-inertial frame of reference. So second one is non-inertial frame of reference or accelerated frame of reference. Accelerated frame of reference. So frame of reference is of two types. First one is inertial frame and second one is non-inertial frame. So non-inertial frame, or we can say accelerated frame. So first keep the heading inertial frame of reference. First write down inertial frame of reference. Inertial frame of reference. So what is the meaning of inertial frame? So write down the important points. First point, this frame of reference this frame of reference is either at rest position or moving with uniform velocity. So this frame of reference is either at a rest position or moving with uniform velocity. Okay, that means what is the acceleration of inertial frame of reference? Zero. So acceleration of inertial frame of reference is 0. And third point, Newton's laws of motion. Are valid in inertial frame of reference. So it is about inertial frame of reference. So generally, for practical conditions, we have assumed earth, okay, that means ground frame. So we have assumed earth as inertial frame of reference. For practical conditions, we have assumed that earth is inertial frame of reference. So you please answer in circular motion. In circular motion, acceleration, for example, I'm taking uniform circular motion. In the case of uniform circular motion, acceleration 0 or acceleration present?
Could you repeat?
0.
Case of uniform circular motion, acceleration 0 or acceleration
present.
perfect.
Acceleration present.
And what type of acceleration present? Centripetal.
Uniform.
Centripetal acceleration will be present. Okay, so if it is uniform acceleration or non-uniform acceleration, in any case, in the case of circular motion, so commonly centripetal acceleration will be present. So we know earth is rotating as well as revolving. So what about earth rotation? Is uniform or non-uniform? Earth rotation, it's a uniform. So even the earth is rotating at a uniform rate. So earth is rotating at a uniform rate, means uniform circular motion. In the case of uniform circular motion, so generally what type of acceleration present? Centripetal. Please keep the mic off. So earth comes under uniform circular motion. In the case of uniform circular motion, so commonly centripetal acceleration present. If acceleration present, so earth, it has to come under non-inertial frame. Okay, in the case of
Sir,
earth,
but in circular motion, centripetal and centrifugal force. No?
Centripetal is the real force, centrifugal is the imaginary force.
Pseudo
Okay,
force.
so only one force we consider, either centripetal force you consider or centrifugal force we consider in numericals. We don't take both forces together.
Both. Okay. I understand, sir. Thank you.
Okay. So generally earth comes under uniform circular motion. In the case of uniform circular motion, centripetal acceleration is present. If acceleration present, it comes under non-inertial frame. But as per practical conditions, we have taken earth as inertial frame of reference. So why? Because so we are doing all the experiments. So for example, you are standing on the earth, I'm standing on the earth. So we both are in the same frame. For example, just imagine that. So two persons are standing in the lift. Lift is moving upwards. Two persons standing in the lift and lift is moving upwards. Now with respect to themselves, they seem to be at a rest position or in motion. Rest position.
Position.
Same thing here. So you are standing on the earth, I'm standing on the earth. So if earth is rotating, so you are rotating, I'm also rotating in the same direction. So with respect to me, you are at rest position. With respect to you, so I'm at rest position. So rest position means, so for practical condition, rest position means, so earth we are taking as inertial frame of reference. For example, you are standing on the earth, I'm standing on the earth. With respect to me, you are at rest position. For example, someone else is observing from the other planet. Someone is observing from the other planet. So from the other planet, for that person, you seem to be still at rest position or in rotation.
Rotation.
But generally here we are doing all the experiments on the surface of the earth. So you are standing on the surface of the earth, I am standing on the surface of the earth, and we both are rotating in the same sense of rotation, same sense of direction. So that with respect to me, you seem to be at rest position. With respect to you, I am at rest position. So because of this practical condition, so we are assuming, not confirming. So we are assuming that, so we have taken that earth as inertial frame of reference. But frankly speaking, earth we can say inertial frame. Frankly speaking, earth is the inertial frame or general non-inertial frame.
General non-inertial.
Non-inertial frame. Why? Because it has acceleration present. But for solving questions, for practical conditions, so we have taken that earth as inertial frame of reference. Okay. So it is about inertial frame. So inertial frame means this frame of reference is either at rest position or moving with uniform velocity. So acceleration 0, Newton's laws of motion applicable. So Newton's laws of motion applicable. And fourth point, for practical reasons, we are taking earth as inertial frame of reference. Right on. Next one is non-inertial frame of reference. Non-inertial frame of reference. Non-inertial frame of reference. Write down first point. It is also nothing but, it is also nothing but, it is also nothing but accelerated frame of reference. Second point, in this non-inertial frame of reference, in this non-inertial frame of reference, Newton's laws of motion, Newton's laws of motion are not applicable in this non-inertial frame of reference. Newton's laws of motion are not applicable, but to apply NLM equations, mean Newton's laws of motion equations, but to apply NLM equations, along with real forces acting on the body, we have to consider a pseudo force. We have to consider a pseudo force. So generally, in the case of non-inertial frame, Newton's laws of motion are not applicable. But to apply Newton's laws of motion equations, so what is the precaution? or what is the suggestion we have to follow to apply NLM equation. So along with real forces acting on the body, we have to consider a pseudo force. So it is about non-inertial frame of reference. Now we will do some questions based upon inertial frame and non-inertial frame. Write on the question. Means next concept, write on next concept. Do
Sir,
one thing.
wait a minute, sir.
You add one more point. Direction of pseudo force. Is opposite to acceleration of non-inertial frame of reference. So for example, if non-inertial frame of reference is accelerating forward, then pseudo force will be in backward direction. So what is the direction of pseudo force? That is opposite to acceleration of non-inertial frame. Therefore, pseudo force equal to minus. This minus indicates direction. Okay, and which direction we have to consider? Opposite direction. So pseudo force equal to minus m into acceleration of non-inertial frame of reference. Now this is the formula to find the value of pseudo force. So pseudo force equal to minus m into acceleration of non-inertial frame of reference. This minus indicates this force direction is opposite to acceleration. This minus indicates pseudo force direction is opposite to acceleration of non-inertial frame. Completed?
No, sir, please 1 minute.
So why is mass there in the formula? It's only opposite to acceleration, right?
Force means mass into acceleration. Na? The force is acting acting on a body. That body mass is m. Okay.
So would you explain the acceleration part again?
So what is the direction of pseudo force is opposite to? So it is opposite to direction of acceleration of non-inertial frame. For example, if non-inertial frame is accelerating forward, now pseudo force acting on the body will be in opposite direction, in the backward direction. Okay.
Thank you.
So here m means the mass of the body on which pseudo force is acting. Okay. Write down the point if you have any doubt. M equal to mass of the body on which pseudo force is acting. Completed?
1 minute, sir.
Right down next concept. Man in a lift. Next concept, man inside a lift. Okay, so in this case, if lift is moving upwards or downwards, okay, so in all the cases we have to find what is the apparent weight of the man. That apparent weight of the man we have to calculate by using inertial frame, by using non-inertial frame. So we calculate, right on, normal force. Okay, right on, normal force acting on the man normal force acting on the man is his apparent weight. His apparent weight. So for example, here I'm taking, it is weighing machine. For example, it is weighing machine. So on this machine, a man is standing to measure his weight. To measure his weight. So in this case, the two surfaces in contact. Okay, two surfaces in contact. When two surfaces in contact, so in this case, weighing machine surface and the feet of the man, so both are in contact. So it is the contact surface. If two surfaces are in contact, so between them, normal force will be present. Between them, normal force will be present. So in this case, so how much normal force acting on the man by the weighing machine? How much normal force acting on the man? Then if it is action force, then how much normal force will act on the weighing machine?
So N.
Same, N. So here, this N value will be measured by the weighing machine. This weighing machine, it measures normal force. So what is the normal force acting on the weighing machine? That normal force it measures. So now this normal force value, will be same or different?
So same.
Same. So why? Because one is action force, reaction force, they have same magnitude. So generally here, so what is the normal force acting on the man? The same normal force is acting on the weighing machine. So this normal force, okay, is measured by weighing machine. This normal force reading is the apparent weight of the man. So this normal force value, so both are same in magnitude. So therefore here, this normal force is nothing but apparent weight of the man. Okay, so so we have some cases. In all cases, we have to find apparent weight. Indirectly, to find apparent weight is nothing but what we have to find indirectly. To find apparent weight means
Normal force acting on the
man.
So normal force acting on the man. So we have to find out the same normal force will acting on the weighing machine that it measures. Okay, so in all the cases, simply we have to find out, so how much normal force acting on the man, that normal force we have to find out. Right on first case. If first case, write down, if lift is moving upwards, lift is moving upwards with acceleration A. Lift is moving upwards with acceleration A. Okay, so for example here, it is a lift and a man is standing inside the lift. So mass of the man, let it be M. And in the question, it is given that lift is moving upwards with acceleration A. So in this case, M is mass of the man, his weight mg, downward direction. His weight mg, downward direction. Now what is the direction of normal force acting on the man by the lift surface?
Upward.
Upwards. So in upward direction, normal force acting on the man. For example here, I'm doing this question by taking observer, this observer is standing on the ground. So ground means inertial frame or non-inertial frame?
So inertial frame.
Inertial frame. Now this question I'm doing by inertial frame of reference. The same question I will do by using non-inertial frame also. The same question I will do by both methods. By using inertial frame, so we are calculating, then after I will do with non-inertial frame of reference. So here observer is standing on the ground. Okay, that means observer is in the inertial frame of reference. You please answer. So in this case, in the case of inertial frame, so we have to consider pseudo force.
No, sir.
No.
Oh,
We have to consider in the case of non-inertial frame. But in this case, the observer is in the inertial frame, so no need to take the pseudo force. Now you please answer. For this a person on the ground, so he seems to be that the person is moving upwards or downwards at a rest position. For this observer, this person, this man seems to be moving upwards.
So
Upwards.
upward.
Yeah, right down. No, what is the resultant force? Resultant force acting on the man? N minus mg or mg minus
minus
mg?
mg.
N minus
minus mg.
Resultant force means mass into acceleration. Okay, so resultant force acting on the man, that is mass into acceleration, equal to n minus mg. From this equation, n equal to, we get mg plus ma. That implies normal force equal to, you take m common, in bracket we have g plus a. I told you already, this normal force acting on the man is nothing but apparent weight. So this normal force is nothing but apparent weight of the man, that is m into g plus a. So here in this case, from this final equation, so for the man mass is m, so what about his true weight? His true weight mg. His true weight mg, but what is the apparent weight? Is equal to mg or greater than mg or less than mg? Is apparent.
Greater than.
greater than
Okay, that means
Greater.
in this case apparent weight is greater than true weight. Okay, so in this case apparent weight of the man is greater than true weight, that is mg. And one more thing here, generally we define weight is nothing but mg. General weight formula is mg. So here we have m, but in the place of g, here what we have, g plus a. So that means when the lift is moving upwards, what is the effective gravity is? In the place of g, here what we have,
G plus A.
So this g plus a is the effective gravity. Effective gravity when the lift is moving upwards. So in this case, so it is one formula we have to remember. When the lift is moving upwards, finding apparent weight m into g plus a, then after in this equation, what is the effective gravity when the lift is moving upwards? That is equal to g plus a. Why? Because this equation, finding effective gravity, is applicable. So in all remaining chapters, in fluid dynamics we follow, in simple harmonic motion we follow, in all remaining chapters we follow this condition. Then in those cases, no need to derive the formula. If lift is moving upwards, straight away we have to take effective gravity is g plus a. Okay, is it clear, the derivation?
Yes, sir.
Okay. Now the same question I'm trying to do by using non-inertial frame. The same question. Okay, let us try to do by using non-inertial frame. So this equation, we have to remember it, effective gravity value g plus a. For example, in fluid dynamics, we take a beaker containing water, and the beaker we kept inside lift. If lift is moving upwards, then how to find buoyancy force? Okay, so those type of question we will do it in the chapter fluid dynamics. For example, a simple pendulum is suspended from the lift. If lift is moving upwards, then how to find the time period of simple pendulum? So in all chapters, somewhere definitely we follow this type of equations, finding effective gravity when the lift is moving upwards. So we got normal force equal to m times g plus a, or apparent weight is m times g plus a. Now this equation, this derivation we had done by taking inertial frame of reference. Now the same question, I'm doing it by using non-inertial frame of reference. So here we have a lift. What is the other name of non-inertial frame?
Accelerated.
Accelerated frame.
Accelerated frame. So he is a man of mass m. Man of mass m. So he is standing in the lift. Lift is moving upwards with acceleration a. So here in this case, mg is weight of the man, downward direction, and n is normal force acting on the man. So in this case, this normal force and mg are the real forces or imaginary pseudo forces. Normal force and mg.
So real.
Real.
These are the real forces. Okay. Now in this case, I'm taking observer inside the lift. I'm taking observer inside the lift. So where is the observer here? Inside the lift. But lift is accelerating. Observer is inside the lift. But lift is accelerating. That means where is the observer? He is present. So he is there in the inertial frame or non-inertial frame.
Non-inertial.
Why? Because so he is standing in the accelerating frame. He is standing inside the accelerating frame. So now he is in the non-inertial frame of reference. So I told you already, in the case of non-inertial frame of reference, along with real forces acting on the body, also we have to consider a pseudo
Pseudo
force.
forces.
Okay, so in the case of non-inertial frame of reference, along with real forces, also we have to consider a pseudo force. And what is the direction of pseudo force? That is opposite to direction of acceleration of non-inertial frame. What is the direction of acceleration of non-inertial frame?
Upward.
Upwards. Then what is the pseudo force acting?
Downwards.
Downwards. And pseudo force acting on this body, acting on the man. So how to draw pseudo force in upward direction or downward direction?
Downward.
Downward.
Then, so what is the value of pseudo force? What is the equation of pseudo force? What is the formula of
Minus.
Don't write minus. That minus indicates we have to follow direction. Already we followed opposite direction. Acceleration of the frame upward direction. So we have taken downward direction.
Plus MA.
So simply
Only MA.
minus only MA. Okay. So it is nothing but pseudo force equal to MA. Then after, just in this case, observer and a man both are in the same frame. Observer and a man both are in the same frame, in the same lift. So with respect to observer, the man seems to be at a rest position. Correct? Why? Because both are in the same frame, right on the point. With respect to observer, man seems to be at rest position. So with respect to observer, man seems to be at rest position. Rest position means on the man forces are balanced or unbalanced. Balanced. So forces are balanced means in upward direction the forces is equal to in downward direction the forces. In upward direction, how many forces acting on the man?
One.
So upward forces equal to in downward direction, how many forces acting?
MA and MG.
Mg plus Ma. Therefore, N equal to M times we have G plus A. The same result we got it in the case of inertial frame, correct?
Yes.
So in the case of inertial frame, what is the normal force? In the case of non-inertial frame, the same result we got it. Okay. Now this result is possible only by taking the pseudo force or not. Yes. This result is possible only by taking pseudo force. So that's why I told you in the theoretical points. So generally in the case of non-inertial frame, Newton's laws of motion are not applicable. But to apply Newton's laws of motion along with real forces, we have to consider a pseudo force. Okay, so that is theoretical points we have in the case of non-inertial frame. Along with real forces, also we have to consider a pseudo force. Okay, so therefore So in the questions, that's up to you. If any question is given, that's up to you. So taking inertial frame of reference or non-inertial frame of reference, the result will be same. Okay. So in this case, observer in the same lift. The same question I will do it by taking observer in the different lift. But let us see here, the same result we get it or different result we get it. We verify all the possible cases. We verify by all possible cases. You please note down. Now, is it clear? Non-inertial frame,
Yes.
the procedure.
Sir, you
Please.
said that with respect to the observer, the man is at rest position, which is why the forces are balanced, right?
Correct.
Okay, thank you, sir.
The same case I'm taking, lift is moving upwards. Same case I'm taking. So here, it is a lift. Lift is moving upwards with acceleration A, and a man is standing inside the lift. So in this case, it is mg. Then after, it is a normal force acting on the man. Now, with respect to inertial frame of reference, with respect to inertial frame of reference, what is the value of normal force acting on the man? With respect to inertial frame of reference, that is m times G plus A. It is with respect to inertial frame. Now, the same question I'm taking by taking non-inertial frame, but a different scenario. So here, man is inside the lift. Man is inside the lift. A lift is moving upwards. Lift is moving upwards with the acceleration A. So m is mass of the man, his weight is mg. Then after, normal force acting on the man in upward direction. But here, observer is inside. So he is the observer. So he is in the different lift. The lift is moving, this lift is moving upwards with acceleration A dash. Now this observer, no, he is inside inertial frame or non-inertial frame. This lift is moving upwards with acceleration A dash. No, this observer frame is inertial frame or non-inertial frame? Non-inertial. Why? Because he is inside a lift and lift is accelerating.
Yes.
Lift is accelerating. Okay. Now this is the case. In the previous case, so we have taken observer in the same lift where the man is standing. Okay, but in this case, observer is standing in the different lift and this lift is moving upwards. Now this observer is observing the man. This observer is observing the man. Okay, so in this case, we have to find what is the normal force. The normal force we have to find out. Draw the figure, please.
Sir, in the type before this, in that also gravity, effective gravity is G plus A?
Yes.
Okay.
What you got, man? M into G plus A, na? So from here to here, your result is changed.
Oh.
And then okay. Now in this case, so is the observer frame.
Sir, this is second case, no?
No, same case continuation. Same case continuation. We are doing the different observer positions. Okay.
Okay, sir. Okay.
So here observer frame also non-inertial frame. Observer frame also non-inertial frame. So now this observer is observing.
Why normal force is in upward direction?
Ma'am, are you sleeping up to now?
So no, I had got disconnected.
Then you see the video later on.
It is there in previous part, sir. Well, today you told.
See, not normal force we completed or not in the previous sessions. Rest of the people, we did or not normal force.
Completed.
Then
yes, sir. Completed, sir.
Then ask the same question: is it completed normal force? That's such a foolish question. So we complete normal force. We had done so many questions on the normal force. Still, we don't know what is the direction of normal force and why it is the normal force acting upwards. So that means it is very clear. You are not studying anything else. Simply time pass. So here observer frame is the non-inertial frame. This non-inertial frame is moving upwards with acceleration a dash. Now you please answer. So now observer is in the non-inertial frame. In the case of non-inertial frame, along with real forces, also we have to consider a pseudo force. But what is the direction of pseudo force? What is the direction of pseudo force?
Opposite to normal.
Opposite to direction of acceleration of
Acceleration.
non-inertial frame. Okay, so here acceleration of non-inertial frame in upward direction. So on the man, in what direction pseudo force will act?
Downwards.
Downwards.
Downward.
So pseudo force acting on the man in downward direction. But you try to recall how to find a pseudo force. Minus we have to write or not necessary?
No, sir,
Not
not necessary.
So m into, what is the
A.
exact formula? A or a dash?
A dash.
A dash.
A dash. Why? Because you refer the formula. Pseudo force is equal to mass into acceleration of non-inertial frame. What is the acceleration of non-inertial frame here? A or a dash?
A dash.
A dash.
A dash.
So it is a pseudo force. And in the previous case, observer and a man in the same lift. Observer and a man in the same lift. So with respect to observer, he is at rest position. But in this case, observer in the same frame or in the different frame? Different frame. So here, so we have to find a resultant force acting on the man. So here resultant force means we have to follow Newton's laws of motion. The Newton's laws of motion are applicable, not applicable? Applicable. Why? Because already I told you
We have used pseudo force.
Perfect. That's the perfect answer. So we have used pseudo force. If we use pseudo force, NLM equations are applicable. So directly here, NLM equations are not applicable in the case of non-inertial frame. But to apply, we have to consider a pseudo force along with real forces. So we have taken pseudo force now easily. So here, so we can apply Newton's laws of motion equations. Okay. Now in this case, with respect to observer, okay, with respect to observer, the man is in the different frame. So the man is in the different lift. A lift is moving upwards. Lift is moving upwards. So therefore, I'm finding a resultant force acting on the man. And the man is moving upwards. You please answer. How to find resultant force acting on the man and lift is moving upwards?
So N minus
N minus M.
N
Please.
minus
M
mg
minus
minus ma
MG.
dash.
बोलने को दो.
N minus mg minus ma
Minus
dash.
ma dash.
Okay. Resultant force means what is the formula? Mass into acceleration. But it is acceleration of the man with respect to observer. Why? Because here observer is observing the motion of the man. Observer is observing the motion of the man. So resultant force equal to mass into acceleration. But whose acceleration? Man acceleration with respect to man acceleration with respect to the observer. Because observer in the same frame, in the different frame. In the same lift, in the different lift. Different lift. So resultant force is equal to mass into acceleration. But whose acceleration we are finding? We are finding acceleration of the man. But with respect to observer. Because observer is observing. Observer is observing. So we are finding man acceleration with respect to observer equal to N minus mg minus ma dash. That implies m into, you follow relative motion conditions, it is nothing but acceleration of the man minus acceleration of the observer equal to n minus mg minus ma dash. From this equation, m means mass of the man. You refer the figure, what is the acceleration of the man? What is the acceleration of the man? A.
So A.
And what is the acceleration of the observer?
A dash.
A dash. And both are in upward direction. Both are in upward direction. So acceleration of the man is A and acceleration of the observer is A dash equal to N minus mg minus ma dash. You multiply individual. So ma minus ma dash equal to N minus mg minus ma dash. Minus ma dash cancel on both sides. Then after ma equal to N minus mg. Minus mg to left side becomes a positive. Therefore, what is the value of normal force equal to? So we are getting the same result or not? Mg plus
Yes.
ma. Okay, so in the case of inertial frame, normal force mg plus me, and in the case of non-inertial frame, in the differential lift, still the result is changed or same?
Same.
Same. So in this case, observer in the same lift. Now what is the normal force? Mg plus me. And in this case, observer in the differential lift. Still, so what is the result we have? N equal to mg plus me. Okay, and in this case, what about observer lift is moving upwards? In the next case, I'm taking observer in the differential lift if lift is moving downwards. If lift is moving downwards, let us verify. We get the same result or the different result. Okay.
Sir,
Are you getting, please?
could you explain after that F-net step?
So F net equal to resultant force means mass into acceleration, correct?
Yes.
Now this resultant force is acting on the man or acting on the observer? This resultant force.
Acting on the man.
Acting on the man. So resultant force is acting on the man. Resultant force means mass into acceleration. But whose acceleration? Acceleration of the man. But this man motion is observed by
Observer.
observer. So here resultant force is mass into acceleration. But whose acceleration? Man acceleration. But with respect to observer. Because observer is observing the motion of the man. Observer is observing the motion of the man. So whatever acceleration we are writing here, that is the acceleration of the man with respect to observer.
Okay, sir.
Please,
Sir,
please.
can you please explain that pseudo force is y equal to mass into a dash?
See, generally you try to recall what is the formula for pseudo force we said, we discussed. Pseudo force equal to minus indicates only
Minus.
direction, minus m into acceleration of non-inertial frame of reference, correct?
Yes, sir.
In this case, what is the acceleration of non-inertial frame of reference, A or A dash?
A dash.
A dash. So pseudo force is mass into acceleration of non-inertial frame, that is A dash.
Yes,
So
sir.
m into A dash.
Sir, does
Please.
it mean that M should be also in the non-inertial frame of reference?
So in this case, we are finding resultant force acting on the man. So on the man, we have to consider pseudo force. Okay. So
No,
in this
sir.
case, please.
Sir, we have written a pseudo force is equal to minus mass into acceleration, then non-inertial frame
Frame
of
of
motion reference.
Okay.
So in that, where we have to consider M in that only, no? Non-inertial
So
frame of reference.
correct. So this man, so whose mass we have to consider? Mass of the man or mass of the observer?
So mass of man.
Mass of the man. So man motion he is observing. Man
Okay.
motion he is observing. So whatever real forces acting, those real forces acting on the man are acting on the observer.
Man.
Man. So mass of the man we have to consider.
Okay, sir. Thank you, sir.
Right on. Same case, I'm taking a different lift. Same first case. Okay, please keep the mic off. For example, I'm taking a lift. So we are taking a lift and a man is standing inside the lift. Mass of the man is m and lift is moving upwards with
Sir,
acceleration.
these are the same case, right?
Same case. Okay.
Okay, sir.
So weight is mg. Normal force acting on the man is n. Now with respect to inertial frame of reference, what is the value of normal force acting on the man? M into G plus A or M into G minus A?
M into G plus A.
M into G plus A. So it is with respect to inertial frame of reference. Now the same question I'm doing it by using non-inertial frame. For example, here it is a lift. Inside the lift, man is standing and mass of the man is m. So his weight mg in downward direction, a normal force acting on the man in upward direction, and I'm taking observer inside a different lift. So he is the observer and he is the observer. So observer is standing in the different lift and this observer lift is moving downwards with acceleration a dash. This observer lift is moving downwards with acceleration a dash. That means here the observer where he is standing, the lift is having acceleration. This lift is having acceleration. Now this frame is inertial frame or non-inertial frame.
Non-inertial.
Non-inertial frame.
Now observer lift is non-inertial frame of reference. Okay, now with respect to non-inertial frame of reference, in the case of man, along with real forces, so here this lift is moving upwards with acceleration. Okay, now you please answer. For this non-inertial frame, what is the acceleration? A dash. For this non-inertial frame, acceleration A dash. So if acceleration of non-inertial frame is A dash, what is the direction of pseudo force acting on the man?
Upwards.
Upwards.
So pseudo force acting on the man is upwards. And what is the value of this pseudo force? M into A or M into A dash?
M A dash.
M into A dash. Is it clear how upwards the formula of pseudo force? These are clear?
Yes, sir.
Okay. Right on. With respect to non-inertial frame of reference, with respect to non-inertial frame of reference, we are finding a resultant force. A resultant force acting on the man, and the man is moving upwards. So man is moving upwards. Now you please answer. What is the resultant force acting on the man? Man is moving
pseudo
upwards.
force minus mg.
Perfect. That is n plus pseudo force is ma dash minus mg. So it's a resultant force acting on the man. But resultant force means mass into acceleration. Mass into, but acceleration of the man with respect to observer equal to n plus ma dash minus mg. Then that implies m into, according to relative motion, it is nothing but acceleration of the man minus acceleration of the observer equal to n plus ma dash minus mg. Then after that implies n, so here mass m into, what is the acceleration of the man, a or a dash? A. Minus, what is the acceleration of the observer?
A dash.
A
But
dash.
a dash
Minus a dash.
minus a dash, because in downward direction, minus a dash equal to n plus ma dash minus mg. That implies m into, it is nothing but a plus a dash equal to n plus ma dash minus mg. You multiply individual ma plus ma dash equal to n plus ma dash minus mg. If you observe here, ma dash, they cancel out. Okay. So after cancellation, we have ma equal to n minus mg. And we have to find a normal force. So we have to find normal force, that is n equal to what we get, mg plus ma. So that means here in all cases the answer will be coming same or not, the result will be coming same or different.
Yes, sir.
Okay,
Same.
so if, okay, please keep the mic off. Still people, they don't know they make their mic is off. So creepy. Yeah, so finally here in all the cases, lift is moving upwards. So you take the question by using inertial frame, by using non-inertial frame of different cases. In any case, so you take the question by solving with respect to inertial frame, with respect to non-inertial frame, the answer will be same. So in any question, that's up to you. So taking inertial frame or non-inertial frame, that's up to you. Okay, so you follow any method, but the final answer will be coming same. You take the inertial frame, so what is the final result? You take the non-inertial frame, what is the final result? That will be same. So the result, it doesn't change. Either you follow inertial frame or non-inertial frame, it doesn't change. Okay, right down. So therefore, the conclusion is when lift is moving upwards, when lift is moving upwards with acceleration A, lift is moving upwards with acceleration A. So how to find apparent weight? Nothing but normal force. What is the formula we have? That is m into g plus A. So when the lift is moving upwards with acceleration A, so it is about normal force acting on the man or apparent weight of the man. Same case, a different point. When lift is moving upwards, the same case I'm taking. Lift is moving upwards with retardation. Lift is moving upwards with retardation. Retardation A. Then how to find apparent weight or normal force acting on the man? Listen here, lift is moving upwards. Lift is moving upwards means already I told you the effective gravity formula. What is the effective gravity formula is G plus A. Same thing here we have to follow. Normal force is M into G plus A. The same formula we have to follow, but in the place of, so G as it is plus, but in the place of A, here what we have to write? Retardation. Retardation means negative acceleration. So we have to follow the concept of G plus A. So in this case, we are following the concept of G plus A. But in the place of A, G plus A concept we are following. Why? Because lift is moving upwards. Lift is moving upwards. We are taking the concept of G plus A. But in the place of A, here what we have to write? Minus A, because lift is under retardation. Therefore, apparent weight of the man is m into G plus, in the place of acceleration, we have to write minus A. Therefore, apparent weight of the man is nothing but normal force acting on the man, that is equal to m into G minus A. So here lift is moving upwards. It is a standard formula. It is standard formula, but so we have to see the condition. If lift is moving upwards by default, we have to follow this formula. If lift is moving upwards by default, we have to follow this formula. But see the lift condition. Lift is moving upwards with acceleration or retardation. Accordingly, this A value we have to change. If lift is moving upwards with acceleration, means plus A, positive A. If lift is moving upwards but with retardation, retardation means negative acceleration. So in the place of A, what we have to write? Minus A. So you please memorize this point. Whenever lift is moving upwards, the default formula is G plus A. But in the place of A, the given conditions we have to follow. So what are the given conditions? Lift is moving upwards with acceleration or with retardation. Accordingly, this A value, we have to change it. So retardation means G plus, in the place of acceleration, we have to write negative acceleration because of retardation. Therefore, from this equation, we can write this apparent weight of the man is less than true weight. Yeah, write down please. In this case also lift is moving upwards but with retardation. So we done both cases. Lift is moving upwards, accelerating. Lift is moving upwards, retardation. In both cases, we have the equation of apparent weight. And next point, same case, first case, next point. And here also I'm taking lift is moving upwards. Here also I'm taking lift is moving upwards. So when lift is moving upwards with uniform velocity, lift is moving upwards with uniform velocity. Uniform velocity means acceleration is 0. Now how to find apparent weight of the man or normal force acting on the man? I told you already, whenever lift is moving upwards, we have to follow m into the default formula is g plus a. But in the place of a, acceleration. When the lift is moving upwards, the default formula is g plus a, but in the place of a, what is the acceleration is given? 0. So g plus in the place of a, 0. Therefore, in this case, apparent weight of the man equal to n equal to mg. So these are the points we have when the lift is moving upwards. Lift is moving upwards, accelerating. Lift is moving upwards, retarding. Lift is moving upwards with uniform velocity. So all these points in the same first case. Why? Because the first case is regarding lift is moving upwards. The first case is regarding lift is moving upwards. So lift is moving upwards, accelerating. Lift is moving upwards, retarding. Lift is moving upwards, uniform velocity. So how to draw pseudo force? Someone is asking how to draw pseudo force. You please refer the theoretical points what we had done. Pseudo force can be drawn opposite to direction of non-inertial frame. Pseudo force can be drawn opposite to non-inertial frame. So here this non-inertial frame moving downwards, non-inertial frame moving downwards. So pseudo force will act upwards in opposite direction. If non-inertial frame moving upwards, pseudo force will act downwards. So how to draw pseudo force that is opposite to non-inertial frame. Okay. Right on, second case. If lift is moving downwards, lift is moving downwards with lift is moving downwards with acceleration a. Lift is moving downwards with acceleration a. Same thing in this case, we have to follow normal force. Okay, those things. So for example, here we are taking a lift. So man is standing inside the lift. Mass of the man is m. So mass is m, weight mg, downward direction. A normal force acting on the man in upward direction. So lift is moving downwards with acceleration a. So here, no need to do it by using non-inertial frame. So in the previous example, it was very clear. in the previous, so in this previous case, it was very clear, either you follow inertial frame or non-inertial frame, the final result will be same. So no need of doing so the both methods all time. So we got the conclusion, either we can follow inertial frame or non-inertial frame, the final result will be same. Okay. So in this case, observer is standing on the ground. Observer is standing on the ground, and we know ground is the inertial frame of reference. Now with respect to inertial frame of reference, now we are finding resultant force acting on the man. Okay, we are finding resultant force acting on the man, and the man is moving downwards. So therefore resultant force acting on the man, that is mg minus n. A resultant force means mass into acceleration equal to mg minus n. The question is, we have to find a normal force. By simplifying it, we get normal force equal to mg minus ma. Therefore normal force equal to m is the common, so g minus a. This normal force is nothing but apparent weight of the man. So apparent weight of the man, that is m into g minus a. So this is the equation applicable when the lift is moving downwards. So therefore here, finally, when the lift is moving downwards, when the lift is moving downwards. So what is the point we have to remember is, when the lift is moving downwards, effective gravity. Effective gravity is G minus A. When the lift is moving downwards, so effective gravity value is G minus A. Therefore, no important points. Therefore, when lift is moving downwards with acceleration A, now we are finding apparent weight or normal force, that is nothing but m into g effective, but g effective we have to write. So apparent weight equal to normal force equal to m into, when the lift is moving downwards, so what is the g effective formula is G minus A, but in the place of A I am writing plus A because lift is accelerating. So therefore it is nothing but apparent weight equal to n equal to m into G minus A. Now this is the concept, this is the formula we have. And from this formula we can write apparent weight. From this apparent weight is less than true weight of the body. So next one is, when lift is moving downwards, with retardation A. Lift is moving downwards with retardation A. Now we have to find apparent weight. The same thing we have to follow. But we know retardation is nothing but negative acceleration. So when the lift is moving downwards, so how to find apparent weight is normal force, that is m into G minus A we have to follow. But in the place of A, what we have to write? Minus A, because retardation is nothing but negative acceleration. So G effective is G minus A we have to follow, because lift is moving downwards. So G effective is G minus A we have to follow. But in the place of A, what we have to write? Negative acceleration, because retardation. Therefore, apparent weight equal to normal force equal to m into g plus A. And from this equation, apparent weight of the body is greater than true weight of the body. Next point, when the lift is moving downwards, when lift is moving downwards, lift is moving downwards with uniform velocity. Uniform velocity means acceleration 0. Lift is moving downwards with uniform velocity. So in this case, we have to find apparent weight or normal force. So here lift is moving downwards. So we have to follow m into g minus a formula we have to follow. G minus a, but a value here 0. Okay, so lift is moving downwards. So effective gravity g minus a we have to follow, but acceleration is 0. Therefore, apparent weight equal to normal force equal to mg. So here all the points we covered. So here lift is moving downwards with acceleration. Lift is moving upwards with lift is moving downwards with acceleration. Lift is moving downwards with retardation. Lift is moving downwards with uniform velocity. So all the cases we completed. So it is about man in a lift. Now we will do some questions. So when the lift is moving downwards, apparent weight is always less than mg? No. When lift is moving upwards, apparent weight is always less than mg? No. So if lift is moving downwards with retardation, if it is moving downwards but with retardation, in this case apparent weight is greater than true weight. So when the lift is moving downwards, so apparent weight always less than true weight, so that is wrong. In some cases, apparent weight may be smaller than true weight. In some cases, apparent weight may be greater than true weight. In some cases, apparent weight may be equal to true weight. So anything is possible depending upon acceleration information. Write down the question. So for example, it is a lift. Inside the lift, we have an inclined plane. Inside the lift, we have an inclined plane. On the inclined plane, we kept a block of mass m. On the inclined plane, we kept a block of mass m. So here I have totally 4 different questions. Okay, in one question, lift is moving rightwards, lift is moving leftwards, lift is moving upwards, lift is moving downwards. So total we have 4 different questions. In all questions, we have to find normal force acting on the block and what is the acceleration of the block with respect to wedge. So it is a wedge. So in all cases, we have to find out normal force acting on the block, and in the same way, we have to find acceleration of the block with respect to wedge. So here I'm taking that. So this angle, let it be theta. First of all, I'm taking this lift is moving rightwards with acceleration A. Lift is moving rightwards with acceleration A. So it is smooth surface. It is smooth surface. So the block slides down. The block slides down. Note down. So in this question, we have to find normal force. Okay, so we will do one thing. I will do first question, the remaining 3 questions as a homework. First of all, here, so you keep in the so you keep this point in the mind. So it is a wedge. Okay, so it is a wedge. So keep the point in the mind. Now let us proceed. So m is the mass. So weight is mg vertically downwards. Then after, this component is mg cos theta, and mg sin theta is down the inclined plane. It is mg sin theta down the inclined plane. Then after, here, this block is in the accelerating frame. This block is in the accelerating frame. So in the accelerating frame, along with, so here normal force will be present in this direction. So it is the direction of normal force acting on the block. So here this block is in the accelerating frame. In the accelerating frame, along with real forces, also we have to consider a pseudo force. Along with real forces, also we have to consider a pseudo force. And what is the direction of pseudo force? Opposite to direction of accelerating frame. So accelerating frame direction rightwards, so pseudo force will act leftwards. Pseudo force will act leftwards. So it is the direction of pseudo force acting on the block. This pseudo force is m into acceleration of the frame. So acceleration of the frame is a, so pseudo force m into a. If this angle is a theta, this angle is a theta, this angle also equal to theta. Okay, this angle with horizontal is a theta, this angle, so if it is equal to theta, this angle also equal to theta. And let us resolve this MA into components. This is pseudo force into components. So it is MA at angle theta. Therefore, this component of pseudo force is MA cos theta. So this component is MA cos theta. Okay, so here it is not visible. Just a minute. So here it is the wedge. So it is MA. Now this component is MA cos theta. MA cos theta. This component is MA cos theta. So this component is MA sin theta. MA sin theta. And in the question, the block is moving down the wedge. The block is moving down the wedge. So it is a direction of motion. The block is moving down the wedge. So it is a direction of motion. So in this case, the block is moving along the inclined plane. Along the inclined plane, the block is moving. So in this direction, the forces will be balanced. In this direction, the forces will be balanced. Therefore, we have N plus MA sin theta is balanced by mg cos theta. From this equation, normal force N equal to, we have mg cos theta minus MA sin theta. So it is a value of normal force acting on the block. Then after, so here the block is moving down the inclined plane. So down the inclined plane, so here mg sin theta down the inclined plane, MA cos theta also down the inclined plane, and these two forces in the same direction. So these two forces in the same direction, therefore resultant force acting on the block, that is nothing but mg sin theta plus MA cos theta. So why plus? Because these two forces acting on the block in the same direction. So mg sin theta, MA cos theta acting on the block in the same direction of motion. So addition. Resultant force means mass into acceleration. Mass into acceleration, but this is the acceleration of the block with respect to wedge. So why? Because block is moving on the wedge. Block is moving on the wedge. So what is the acceleration of the block Now this acceleration of the block is with respect to wedge. So resultant force is mass into acceleration. The exact meaning of this acceleration is acceleration of the block with respect to wedge. Equal to on right hand side, equal to, so we have mg sine theta plus me cos theta. So m cancels on both sides. Therefore, the final equation is acceleration of the block with respect to wedge equal to g sine theta plus a cos theta. So this is the value of normal force acting on the block and acceleration of the block with respect to wedge. So in all the cases, the same values we have to find out. So we have to find a normal force and we have to find the acceleration of the block with respect to wedge. In all cases, the same process we have to follow. mg we have to resolve into components and me also we have to resolve into components. The same type of logic we have to follow in all the questions. Please note down. Next question. For example, it is a lift. It is a lift. So inside the lift, we have a wedge and this angle is a theta. Lift is moving leftwards with acceleration A. So on this wedge, we have a block. On this wedge, we have a block of mass m. Same thing, we have to find a normal force acting on the block and we have to find the acceleration also. So m is a mass, so its weight mg. Then after, it is mg cos theta. It is mg cos theta. Then after, it is mg sin theta. This component is mg sin theta. Then after, it is the normal force acting on the block. So all these are the real forces. All these are the real forces acting on the block. But this block is in the accelerating frame. This block is in the accelerating frame, means non-inertial frame. In non-inertial frame, along with real forces, also we have to consider a pseudo force. But how to draw pseudo force opposite to direction of acceleration of non-inertial frame? So here acceleration of non-inertial frame leftwards, so pseudo force rightwards. So here pseudo force rightwards. It is the direction of pseudo force, that is mass into acceleration of the frame, that is A. Then after this pseudo force, we have to resolve into components. Pseudo force, we have to resolve into components. See one thing, so here with horizontal, this angle theta, same with horizontal, this angle theta. So with horizontal, this angle theta, with horizontal, this angle is theta. Now MA resolve into components. Now this component is MA cos theta and this component is MA sin theta. So these are the components of pseudo force. And in the question, it is given that the block is moving down the wedge. Block is moving down the wedge. So therefore, if the block is moving down the wedge means in this direction, the forces will be balanced. In this direction, the forces will be balanced. So therefore, normal force N is balanced by mg cos theta plus ma sin theta. It is about normal force. So first question completed, finding normal force acting on the block. So coming to second question. So here the block is moving down the wedge, So therefore we are writing dynamic equation. So resultant force acting on the block. The block is moving down the wedge. So down the wedge means what we have to write, mg sin theta minus ma cos theta. A resultant force means mass into acceleration, but acceleration of the block with respect to wedge. So acceleration of the block with respect to wedge equal to mg sin theta minus ma cos theta. So here on both sides m value cancels. M value cancels, therefore acceleration of the block with respect to wedge equal to, we have g sin theta minus a cos theta. So how we got F net? So in this case, the block is moving down the wedge. So we have mg sin theta in this direction and ma cos theta in this direction. The motion is downwards. Then how to find net force acting on the block is mg sin theta. With respect to mg sin theta, ma cos theta will be in opposite direction. With respect to mg sin theta, ma cos theta in opposite direction is a resultant force acting on the block. So it is the direction of motion of the block. Direction of motion of the block. Next question. For example, here we have a lift. Lift is moving upwards with acceleration a, and this is wedge. And we kept a block. We kept a block of mass m. And same thing we have to find a normal force, and also we have to find acceleration. So both equations we have to find out. Okay, so m is mass of the block, so its weight is mg. Its weight is mg. Then after, this component is mg cos theta. This component is mg cos theta. Now this component is mg sin theta. This component mg sin theta. This component is normal force acting on the block. But in this question, the frame is moving upwards with acceleration. So what type of frame it is? So it is non-inertial frame because it has acceleration. In the case of non-inertial frame, along with real forces, also we have to consider a pseudo force. We have to consider a pseudo force. Okay, so if acceleration is upwards, we have to draw pseudo force in opposite direction. So how to draw pseudo force opposite to direction of acceleration of non-inertial frame? So acceleration of non-inertial frame upwards, so pseudo force will affect in downward direction. So pseudo force acting in downward direction. It is pseudo force MA. And same thing you resolve into components. Now this component is MA cos theta, and this component is MA sin theta. So these are the components of pseudo force. See, very simple. So it is mg. So mg cos theta, mg sin theta. In the same way, in the same direction, we have MA is present. So how we resolved mg into components? In the same way, we have to resolve MA into components. So it is MA cos theta and MA sin theta. So therefore here, in this case, the block is moving down the wedge. It is a direction of motion. Block is moving down the wedge. So if the block is moving down the wedge, so in this direction, the forces will be balanced. So in this case, normal force is balanced by mg cos theta plus ma cos theta. Therefore, normal force equal to, you take m cos theta common. M cos theta common, in bracket we have g plus a. So it is about normal force acting on the block. Then after, So in this case, the block is moving down the wedge. Block is moving down the wedge. So here this force down the wedge, this force also down the wedge, and these two forces acting in the same direction of motion. These two forces acting in the same direction of motion, therefore resultant force equal to, so in the same direction, so addition mg sine theta plus ma sine theta. Resultant force means mass into acceleration, but acceleration of the block with respect to wedge equal to, so you take m common and sine theta common. On right hand side, m common, sine theta common, in bracket we have g plus ea. So m cancel out, therefore acceleration of the block with respect to wedge equal to, we get g plus a into sine theta. So it is about acceleration of the block with respect to wedge. Next question. So here we have a lift. But this question you try as a homework. Okay. We have a lift moving downwards with acceleration a. Then after it is a wedge. On the wedge we have a block, and the block mass is m. In the question, block is moving down the inclined plane. So it is acceleration of the block with respect to wedge. Now this is the question. So you have to find out normal force acting on the block, and you have to find out acceleration of the block with respect to wedge. So this case you try as a homework. Next question. So for example, it is a wedge and theta is the angle. On the wedge, we kept a block of mass m. We kept a block of mass m. So in the question, it is given that this wedge is moving rightwards. Wedge is moving, okay? Wedge is moving rightwards with acceleration capital A. Wedge is moving rightwards with acceleration capital A. Write down the question, find acceleration of the wedge, but that means capital A we are finding acceleration of the wedge means capital A we are finding, so that the block will be at rest position. The block will be at rest position on the wedge. So it is a question. Find acceleration. So this question I will do it. And we have one more question. In the same question, find normal force. Find normal force acting on the block. Normal force acting on the block by the wedge. So totally two questions we have to solve. One is acceleration we have to find, Normal force also we have to find out. So very simple one. In this question, m is mass of the block, so its weight mg vertically downwards. Now this component is mg cos theta, this component mg cos theta, then after this component mg sin theta, mg sin theta, then after it is normal force acting on the block. But in this case, wedge is having acceleration. It is having acceleration. So wedge, it comes under non-inertial frame. So wedge comes under non-inertial frame because acceleration of the wedge is given. So wedge is a non-inertial frame. In the case of non-inertial frame, along with real forces, pseudo force also acts on the body. Pseudo force also act on the body. But how to draw pseudo force opposite to direction of acceleration of non-inertial frame? So it is a direction of, so rightwards is the acceleration of non-inertial frame. So pseudo force leftwards. So it is ME, pseudo force acting on the block. Then after, so here this is pseudo force, we have to resolve into components. Pseudo force we have to resolve into components. So it is very simple. If this angle is a theta with horizontal, this angle theta with horizontal, so that over here also the angle is theta because same horizontal here. So theta with horizontal, so theta with horizontal. So therefore this MA, so it is MA, this angle theta, you resolve into components. Now this component is MA cos theta and this component is MA sin theta. This component is MA sin theta. So mg we resolve it into components and pseudo force also we resolve it into components. And in the question it is given that the block is at rest position. That is given in the question. See here, the block is at rest position. So if the block is at rest position means on the block the forces are balanced. Okay, sorry, here it is capital A. This acceleration capital A. This acceleration capital A, same thing, it is a capital A, MA cos theta, and same thing, it is MA sin theta. MA sin theta. So because acceleration of the frame is given capital A. Acceleration of the frame capital A, so pseudo force M into capital A. So MA cos theta, MA sin theta. In the question, with respect to wedge, the block is at rest position. So block is at rest position means in all direction, forces are balanced. So in this direction, what are the balanced forces? In this direction, what are the balanced forces? Mg sin theta balanced by MA cos theta. So it is given that block at rest position. Block at rest position, that means forces are balanced. So what are the balanced forces? First of all, here this M capital A cos theta and Mg sin theta are balanced. So MA cos theta is balanced by Mg sin theta. Therefore here M cancel out. After cancellation, A cos theta equal to G sin theta. But the question is we have to find acceleration capital A. So therefore from this equation capital A equal to, we get G tan theta. So it is about acceleration of the wedge. So first question completed. Finding acceleration capital A, that we got it, G tan theta. The second question, we have to find a normal force. But if we observe the free body diagram, from the free body diagram, this normal force should be balanced by these two forces. This normal force is balanced by these two forces. Therefore, normal force equal to mg cos theta plus m capital A sin theta. Now this we have to simplify it. N equal to, we have mg cos theta plus m into, in the place of capital A, I am writing g tan theta. In the place of capital A, we are writing this result, g tan theta into sin theta. That implies n equal to mg cos theta plus mg. In the place of tan theta, we are writing like sin theta upon cos theta. So tan theta, we are writing like sin theta upon cos theta into, again we have sin theta. Therefore, n equal to, you take mg is the common. If mg is the common, so here we have cos theta plus this mg already common. This mg already common. So what we left with, sine square theta, sine theta into sine theta. So sine square theta upon cos theta. So sine square theta upon cos theta. By taking mg is a common. That implies n equal to mg in brackets, you take the LCM. By taking LCM, cos theta into cos theta. By taking LCM, cos theta into cos theta is cos square theta plus sin square theta. In denominator, the LCM is cos theta. Therefore, n equal to, it is nothing but mg sin square theta plus cos square theta is 1 upon cos theta. Therefore, the value of normal force, the final equation is mg upon cos theta. So it is the final equation, finding normal force acting on the block. So mg sec theta also correct answer. Mg upon cos theta or mg sec theta, so both are correct. So this also nothing but mg sec theta. Right now, next question. For example, here we have a car. We have a car. So from the car, a pendulum is suspended. Pendulum is suspended. So its mass is m. Mass of the pendulum is given m. If the car is moving forward with acceleration a, okay, if the car is moving forward with acceleration a, the pendulum will deflect backwards because of pseudo force. Okay, why? Because here car is what type of frame? So car is having acceleration. So car is the non-inertial frame. In the non-inertial frame, pseudo force will be present. So how to draw pseudo force? That is opposite to direction of the frame. So here acceleration direction forward, so pseudo force will be acting backward. So because of pseudo force, the pendulum will deflect backwards. So it moves backwards through angle theta. The theta value we have to find out. So due to pseudo force. So it is a pseudo force, MA. So due to pseudo force, the pendulum will deflect backwards through angle theta. So find a theta. So that is a question. Find a theta, and we have to find a T tension of force. So both we have to find out. So it is a tension of force. So it is a string. It is a string. So we have to find a theta, and we have to find a T tension of force. Both we have to find out. Okay, listen. In this case, m is mass of the pendulum, so its weight is mg. Its weight is mg. Then after, so here pendulum is the body we are taking. If this is the body and this is a string, this is the body, this is the body, and this is the string. So what is the direction of tensional force in the string? Away from the body, away from the body along the string. Okay, so here it is the direction of tensional force in the string. Now resolve into components. Tensional force we have to resolve into components. If this angle is equal to theta, if this angle is equal to theta, and this angle also equal to theta, this angle also equal to theta. Now this angle equal to theta. Now this component of tensional force is a T cos theta, and this component of tensional force is a T sin theta. So these are the components. So here it is the tensional force. If this angle theta, this angle also theta. It is a T tensional force angle theta. This component is T cos theta, and this component is T sin theta. So now we have to find a theta value. To find theta value, I'm taking observer. I'm taking observer in the same frame. I'm taking observer in the same non-inertial frame. I'm taking observer in the same frame. Just you please imagine that like lift case. In the case of lift, if the man observer in the same lift, if man observer in the same lift, so with respect to themselves, they seem to be at rest position. In the same way, so here observer and the body simple pendulum, observer, the body, simple pendulum in the same frame. So in the same frame, that means with respect to observer, the pendulum seems to be at rest position. Why? Because both are in the same frame. So both are in the same frame. So with respect to observer, the pendulum seems to be at rest position. If pendulum is at a rest position, forces will be balanced. Forces will be balanced. Right on the point. So here observer and pendulum, observer and pendulum in the same frame, so with respect to observer, pendulum seems to be at rest position. Pendulum seems to be at rest position. So pendulum seems to be at rest position means forces are balanced. So what are the balanced forces? So here you see the free body diagram. So what are the balanced forces? T sin theta is balanced by MA. So the first set of balanced forces, first one is T sin theta is balanced by MA. Let it be first equation. And what is the second set of balanced forces? T cos theta is balanced by mg. T cos theta is balanced by mg. So here T cos theta is balanced by mg. It is second equation. So the question is we have to find a theta and we have to find a T tension force. So that is a question. So Aryan correct answer. Aryan correct. So here by balancing forces, these are the equations we have. So do one thing, equation 1 upon equation 2. You divide both equations. Equation 1 upon equation 2 means t sine theta upon t cos theta equal to, in the same way, ma upon mg. Equation 1 upon equation 2. So tt cancel out, cancel out, sine theta by cos theta is a tan theta. So tan theta equal to a upon g, that implies theta equal to tan inverse of a upon g. So it is the first question, finding theta value. Then after, so second question, also we have to find a T tension force. To find T tension force, what I'm doing is equation 1 square plus equation 2 square. Okay, this I'm doing it. So first of all, what is the equation 1? It's a squaring part, T square sine square theta equal to m square a square. So we have equation 1, it's a squaring, so squaring on both sides. In the same way, now equation 2 squaring part, equation 2 square, that we get t square cos square theta equal to m square g square. Then after, so equation 1 square completed, equation 2 square completed, next we have to add them. So we have to add both equations. Now we are adding both equations. So in the addition, left side t square is the common. If a t square is the common, we have sine square theta plus cos square theta. In the same way, on right hand side addition, m square is the common. If m square is the common, we have g square plus a square. So sine square theta plus cos square theta, that is 1. So t square into 1 equal to, we have m square in bracket g square plus a square. So t square into 1 is nothing but a t square. So therefore t square equal to, we got m square into g square plus a square. Therefore we require t value. So t square, t means root over. We get m into root over g square plus a square. Now it is the value of tension force in the string. Okay, so just we require one more lecture, then this whole NLM laws of motion will be completed. Just we require just one more lecture. So we left with only wedge constraint. In wedge constraint, we have roughly 10 questions are there. If we do 10 questions, then this whole laws of motion will be done. Okay. So I think you can solve it. The H.C. Verma, I think at least 70% of questions you can do it from H.C. Verma. Maximum we try to cover all variety of questions from the H.C. Verma. You can do it H.C. Verma also. Okay. So that's it for the day. So in the next lecture, we will do with wedge constraint. In wedge constraint, roughly we have 10 questions are there. If 10 questions are completed, now we're done with NLM chapter. Then we start with friction. Okay. So bye. Take care.